Cross product to find the area of a parallelogram and the angle between the vectors. So we're going to use these two vectors u and v as the adjacent sides of a parallelogram. So let's draw that out here. I use GeoGebra to graph these vectors. And so the idea here is we have a parallelogram where the height is here at 90 degrees, which will be needed to find the area. So the base is our vector v, and here on the hypotenuse of this triangle is our vector u. So the area of a parallelogram is the base times the height, and the height is at 90 degrees. Alright, so the base we see is the magnitude of the vector v. Now the height, you have to do a little trickiness here. If this is our angle theta, we see that's opposite over hypotenuse, so h over the magnitude of u. Solving for h, that's the height, so now our area is the magnitude of v times the magnitude of u times sine theta. And notice that's actually the definition for the magnitude of the cross product of v and u. So, to find this area, we just need to find the magnitude of the cross product of these vectors. Notice I can find the magnitude of each individual vector, so the magnitude of u would be 1 squared plus 1 squared plus 3 squared square rooted, which gives us the square root of 11, and the magnitude of v, which would be 4 squared plus negative 1 squared plus 1 squared square rooted, so that's 16 plus 1 square rooted, and that's the square root of 18, which can be reduced to 3 root 2. Plugging this into our area formula, we would get square root of 11 times 3 square root 2 times sine theta. You can simplify that, but you can't find the answer since you don't know sine theta. So we will have to find the cross product. I'm going to use the 3x3 matrix determinant trick. So if you don't know this, make sure you look that up, but I'm going to do it quickly here. And the trick is that you kind of extend it by the first two columns again, and then you just input for the middle row one of your vectors and the last row the other vector. And then just repeat the last two columns kind of on the outside of the determinant. Then you multiply just diagonally across. When you multiply up, you have to multiply that thing by negative. So just multiplying the diagonals, 1 times 1 times I, 3 times 4 times j, which is 12j. And then you also multiply diagonally down. So negative 1 times 3 times I, j times 1 times 1, k times 4 times 1, and then you put them all together. So I have negative 3i plus j plus 4k, and then I'm going to distribute that negative sign for the top part that I did. And then let's combine like terms. So my i's, I have negative 3i and negative I for negative 4i. I have my j's, I have positive 1j, negative 12j for negative 11j. I have 4k and k for 5k. Now I could find the magnitude of the cross product by squaring each individual term, and then of course taking the square root of that. So 16 plus 121 plus 25 square rooted. This ends up giving me 162 square rooted, which is 2 times 81. So I could take out the 9 and leave the 2 in the square root. And this is actually the area of the parallelogram, and it's the magnitude of the cross product. Notice now that I have the area, I can use this other formula for the area of the magnitude of v times the magnitude of u sine theta to find the angle between u and v. Because now I know the area is 9 root 2. So it's there, formula up there. So simplifying this, I get 3 square root 22 sine theta equals 9 root 2. I could divide both sides by that 3 square root of 22. And properties say I could simplify this, so the 9 and the 3 just simplifies to having a 3 on the top. And there's a rule that says you can put this whole thing kind of in a square root. So I have square root of 2 over 22, and I could simplify within the square root to get 1 over 11 square rooted. And then of course, square root of 1 is 1. and I could rewrite this to be 3 over square root of 11, and then I could take a sine inverse or arc sine to get my angle, which ends up being 64.76 degrees. And so that's the angle right here that I'm going to mark in purple. And now we have our angle and the area of the parallelogram.